In this lesson, we're going to look at a typical application problem dealing with density and volume. So for this scenario, we're looking at trees that are cut down and stripped of their branches for timber, and we're going to approximate them to be cylinders. So a timber company specializes in a certain type of tree that has a typical diameter of 50 centimeters and a typical height of 10 meters. The density of the wood is 380 kilograms per cubic meter, and the wood can be sold by mass at a rate of $4.75 per kilogram. We want to know what's the minimum number of whole trees that must be sold to raise at least $50,000. So lots of information. So let's kind of go back through and highlight some of the important things. So the trees, we're going to approximate that they're cylinders because all the branches have been removed from them. The diameter of these trees are 50 centimeters and a typical height of 10 meters. Right away, I'm noticing some unit conversions because I have centimeters and meters. So here's my cylindrical tree. I know that the height is 10 meters. And this is just an estimate for the typical tree. And the diameter is 50 centimeters, which means that the radius is going to be 25 centimeters. We know that the density is 380 kilograms per cubic meters. Now remember, that density really tells you a lot about what you need to do with your units. So your weight that you're going to get is going to be in kilograms. Your volume needs to be in cubic meters if you're going to be using this density. So right away, this is telling me these dimensions that I'm going to use for the volume need to be in meters. So this 25 centimeters, I'm going to take care of that right away and get that into meters. So a couple ways to think about your conversion here. If you remember that acronym, King Henry died unusually drinking chocolate milk. So units would be where your meters are. So if I'm thinking about meters, that's just a unit. Centi is right here, so centimeters. So if I'm starting with centimeters, I need to go backwards 2 decimal places to get to meters. So that means my 25 centimeters, my decimals at the end, needs to go back 2 decimal places. So this becomes 0.25 meters. So right away, I'm going to cross that off and I'm going to write 0.25 meters instead. Another way to do this is to use your conversion factor. That 1 meter is 100 centimeters. So if I have 25 centimeters, you could set up a proportion using this conversion, or you could just multiply to use the scale factor to get rid of the units. So I want to get rid of centimeters, so that means I'm going to put the 100 centimeters at the bottom so that these cancel out, and then the 1 meter on top. Multiply across, so what ends up happening is it's 25 over 100 when you multiply. I'm going to put meters at the end. So that ends up giving me 0.25 meters. So either way, different ways to think about it. Some of you would just know, okay, just divide it by 100. That's essentially what I'm doing here. So I get my conversion. And then the wood can be sold. So another important piece here, if I continue reading the question, is that it can be sold by the mass at a rate of $4.75 per kilogram. So what this is doing is this is telling me I need to know the mass. Must find the mass, which is a typical situation that you're going to run into where you're going to have to find the mass because, like I said, they'll give you the density. That typically is what happens, not always, but most of the time they'll give you the density. They'll give you enough information to find the volume, because if you remember your density formula equals mass over volume. If you know your density and you know your volume, you can solve for the mass. So that's really our goal here, is to find the mass, because if we know the cost per kilogram, we can then figure out the 50,000, how much we need for the 50,000. So let's go ahead. So I did my conversion. So my first step here is going to be, we want to find the mass. So in order to find the mass, we are going to use our volume. We're going to find volume so that we can use our density formula. So I'm going to first find the volume. So it's a cylinder, so pi r squared times h. So I'm going to plug in, now that I have everything converted to the units that I want according to my density. So the radius is 0.25 meters. The height is 10, and this makes sense. A tree should be much taller than the radius of it. And I'm going to go ahead and leave this right in terms of pi because I want exact values here until the end. So when I multiply this, I get 0.625 pi. Keeping your units is going to be very important here. So this is in cubic meters. So there's my volume. Now what I can do, now that I know the volume, I can find the mass. So we have our volume, or our density equals mass over volume, or you can think of it as the triangle we talked about. So the density equals mass over volume. So we're trying to find the mass. So what that means is you cover up the mass, and mass is equal to density times volume, or you plug into this and cross multiply, either way. So I'm going to just use this formula here. So mass equals density times volume. So my density is given to me in the problem, 380 kilograms per cubic meters. Notice I'm keeping the units, that's important. And then I have the volume, 0.625 pi meters cubed. Again, being careful with those units. Now I see that these meters cubed are going to cancel, ones in the numerator, ones in the denominator. So my mass, when I multiply these, will be in kilograms. So 380 times 0.625. I'm going to go ahead and leave this in terms of pi again, so meaning I'm not going to enter pi in my calculator. So it's 380.625 gives me this 237.5 pi kilograms. That's my mass. So that's how much one tree, so this is the mass for one tree. I want to know how many trees do I need to sell to get $50,000. So what I now need to do is find the cost for one tree if I'm going to get $4.75 per kilogram. So let's go ahead and find one tree, what you get. So let's say price for one tree. So it's going to be, I'm going to say 475 times the mass of one tree, because they're sold by the weight. Don't forget that pi. Otherwise, if you don't like leaving pi, you could put the entire decimal, but just make sure that you use the entire decimal in your calculator when you're doing the calculations. So 4.75 times that 237.5 pi is giving me 3,544.1092123331. I'm not going to round to money. I know it seems weird not having two decimal places for money, but I want to wait until my final answer. So that's what you get for one tree. We want to know how many trees to get $50,000. So now what I'm going to do, if I get 3,500 for one tree, well, how much does it take for to get to 50,000? So I'm going to take the 50,000 and I'm going to divide that by that entire value, not rounding. So I was going to put dot, dot, dot. And 50,000 in my calculator divided by, I'm scrolling up to that entire number. I'm getting 14.107 dot, dot, dot. So I'm going to keep this as an equal sign. And then that would mean approximately, if we sold 14 trees, you're not going to get that 50,000. You have to sell 14.1 trees to get 50,000. So that really means you need to get 15 trees to be able to get at least 50,000. So what's going to happen is you'll get a little bit more than 50,000. So you would need approximately 15 trees to meet that goal. So like I said, these are common application problems where you're figuring out the mass and you're figuring out the price based on the mass, or maybe you're figuring out can a trailer or a wheelbarrow hold the items by their mass. So being able to go from density, calculate the volume, and get to the mass is really what you need to be able to do. And then the last couple steps are going to depend on the scenario that you're given. So write down whatever you think for key ideas, and then try the one application problem.